Welcome to the first problem set of the subject Signals and Systems. In this video, we will first solve some of the questions taken from the book back of the book Signals and Systems by Alan V. Oppenheim, and then we'll see some previous year GATE questions based on this topic. So let's get started. So the first question is, a continuous time signal x of t is shown below. Okay, this is the signal. And they're asking to sketch and label carefully x of 2 minus t and x of 2t plus 1. Okay, so this they have given it as x of t. Okay, and we need to plot x of 2 minus t and x of 2t plus 1. So first let us try to plot x of 2 minus t, right? So the approach I'll be taking is, first we'll be doing the time shifting operation. And then we'll do the time scaling or reversal. Okay, so for x of 2 minus t, first I have to do x of t plus 2. So what is x of t plus 2? So t here. I have 1, 2. So t plus 2 meaning shifting x of t to the left by 2 places, right? So minus 1, minus 2, minus 3, minus 4. And if you see, it starts from 2. So here I have to start from 0. So from 0 to 1 it is like this. And then from 1 there is a increase in the amplitude. So this is 1, 2. Okay, and that from minus 1 to minus 2, it remains 2, and then it drops back to 1, and then it remains 1, right? And then it goes to 0, and from there it linearly increases to minus 1. So this is x of t plus 2. Now I have to just do the time reversal. So x of minus t plus 2. This is nothing but x of 2 minus t. Right? So if I just have to do a time reversal of this, what will I have? So here you can see all the signal is present on the left hand side. So everything will come on the right hand side. So 1, 2, 3, 4. I have 1, 2 and minus 1. So initially it is starting from 0, goes to 1, right? And then it goes to 2, stays at 2. And then comes back to 1, and then stays at 1, then goes down to 0, and then from here it linearly decreases to minus 1, and then again comes back to 0. So you can see these two signals are the time reversal of each other, and this is the required signal for us. So this is the answer for option A. And option B, it is x of 2t plus 1. Alright, again we'll start by doing the time shifting. So we'll first plot x of t plus 1, shifting x of t to the left by 1 unit. So it will start from 1, minus 1, minus 2, minus 3, right? It will go until minus 3. So from 1 it goes to 1 here. And from here it goes to 2, and it stays in 2, comes down back to 1, and stays in 1, right, this part, and again goes to 0, and then from 0 it decreases to minus 1, and then comes back to 0 again. Okay, so this is x of t plus 1. And then we have to just do the time scaling in the next step. So x of 2t plus 1. So here 2 is greater than 1. So what will happen? It will shrink in time, right? Time compression. So what will happen? So the amplitudes will remain same. And 1 will actually go to half, right? And minus 1 will go to minus 0.5. And then we have minus 1. And then we'll have minus 1.5, correct? So the structure will look similar. It's just a compression in time. So it is first scaling, then goes to 2, remains in 2 until minus 0.5, and then remains in 1 up to minus 1, and then at minus 1 it comes to 0, right? Here it is 2, so here it will be minus 1, and then it goes to minus 1 here, and then comes back to 0 at minus 1.5. Okay, so this is our desired signal, x of 2t plus 1. So you can just take a moment to observe what I have done. So if you're also comfortable with the second way, where we first do the time scaling and then do the time shifting, then you have to approach like this, right? So second way. So for A, it will be, first you have to, let's say first you do the time scaling or reversal. Then in the second step, you should actually do right shift by 2 instead of a left shift, correct? You need to do right shift so that you get this as x of 2 minus t. Okay. And in the second case, what you have to do is, so first you are doing the time scaling. So you will get x of 2t. Then you need to actually left shift by half. So then only you will get x of 2t plus 1. Okay. So you have to keep these in mind. So moving on. Determine whether the following signals are periodic. If they are periodic, find the fundamental period. Okay. So the first signal we have is x of t is equal to E1 of cos 4 pi t u of t. Okay. So x of t is E1 of cos 4 pi t u of t. So we already saw how to define a even function, right? So E1 of sum w of t is nothing but w of t plus w of minus t by 2. So this is a even decomposition of a signal, right? Even part of a signal. Similarly, you can write x of t that way. So it will be cos 4 pi t u of t plus cos of minus 4 pi t u of minus t by 2. But if you observe, cos of minus x is nothing but cos x itself. So this is nothing but cos of 4 pi t u of t plus cos of 4 pi t u of minus t by 2. And you can see the cos 4 pi t is actually common. Then you have u by 2 also, you can take it out. So you have u of t plus u of minus t. So if you see, u of t is 0 for t less than 0 and 1 for t greater than 0. And this is actually 0 for t, 1 for t less than 0 and 0 for t greater than 0. Okay. So together what will it contribute? Yes, it will be 1 throughout for all t. At 1 again, at t equal to 0 again, it is not defined. But for this case, we can take it, the value, the addition is still comes to be 1. Okay. And actually for this question, it will matter, but since they're asking for periodicity, right? So we'll still assume that at t equal to 0, the sum is 1. Okay. So in that case, this x of t will just be cos 4 pi t by 2. Okay. Now you know cosine is actually periodic. So this is periodic. If you want to see, let's say x of t plus t naught for some t naught, then we'll get cos of 4 pi t plus t naught by 2. And this is nothing but cos 4 pi t plus 4 pi t naught by 2. And you know cos x plus 2 pi is equal to cos x. So cosine is periodic with a period of 2 pi. So 4 pi t naught equal to 2 pi. So t naught is nothing but 2. So it is periodic. So x of t is periodic. And the fundamental period is correct? Because we got t naught as 2, the minimum possible. So here it is actually 2n pi. You can also write here 2n pi. In that case, this will be 2n. And the fundamental period is nothing but the minimum period. So it comes for n equal to 1. Okay. So in the second part of the question, we have this signal, right? X of t is equal to summation n equal to minus infinity to infinity e power minus 2t minus n u of 2t minus n. Okay, so let's go to a new page. So what we have is x of t is equal to summation n equal to minus infinity to infinity e power minus of 2t minus n, right? And u of 2t minus n. Okay. So now again we'll just check whether if it is periodic or not periodic. And for your sake, you can just try to guess before starting the question. Okay, if you have made your guess, let's then proceed. So let's just find x of t plus t naught. Summation n equal to minus infinity to infinity e power minus 2 into t plus t naught minus n u of 2 into t plus t naught minus n. And we have n equal to minus infinity to infinity e power minus 2t plus 2t naught minus n u of 2t plus 2t naught minus n. So now we have this extra term 2t naught minus n. So we can just try to replace it. Okay, so 2t naught minus n is equal to, let's say, minus m. Let's call it minus m. So then this is just a change of variable. Okay. So then how will the limits change? So m is nothing but n minus 2t naught. So for n equal to minus infinity, m will also will be equal to minus infinity. And n equal to infinity, m is also equal to infinity. This is how the limits will change. So m is equal to minus infinity to infinity e power minus 2t, this is minus m, correct? And u of 2t minus n. And now if you see, this is just a change of variable, correct? Again, I can replace m to n. Because x of t itself is not depending on m. It is just used as a variable for the summation. So we can change it. Minus 2t minus n u of 2t minus n. But what is this? This is nothing but x of t itself, correct? So this is equal to x of t. So x of t plus t naught is equal to x of t. So x of t is periodic. So if you have initially guessed that it is not periodic, maybe you can take another look at the derivation and convince yourself why this is periodic. And we need to find the period, correct? So we need to take this equation. So 2t naught minus n is equal to minus m. We need to find t naught, right? So 2t naught is equal to n minus m. So if you see n and m, they are integers, correct? So they can take n comma m is equal to some minus 3, minus 2, any number of values, 0, 1, 2, and so on. So n minus m is also nothing but, it should be an integer, correct? So 2t naught should belong to integer, right? So let's say 2t naught is equal to some integer, let's say a. Okay, a is an integer. So what will t naught be equal to? T naught will be a by 2. Okay. And what value does a take? A is, let's say t naught is, it can be positive or negative. So it can take any values, minus 2, minus 1, 0, 1, 2, right? And we need to find the smallest possible t naught, which is a positive t naught for the definition of period, right? And if you take 0, then it is actually the same signal, right? You need to take some value greater than 0, which is nothing but 1. So t naught is equal to half. So this is the fundamental period. So the fundamental period is half. So you can also try to visualize this. So I'll again take this function. Let's copy it down here. If you actually try to expand this, you will have some terms. And then let's take it for n equal to minus 1. What will you have? It will be e power minus 2t plus 1, u of 2t plus 1, correct? And for n equal to 0, it is e power minus 2t, u of 2t. And for n equal to 1, it is e power minus 2t minus 1, u of 2t minus 1, and so on, right? Now you just replace t with t plus half. Then what happens? You have the same terms. So the n equal to minus 1 term will go to e power 2t. Okay, let's say it is minus half. So it will be 2t minus 1 plus 1, which is nothing but 2t itself. And same for u of 2t minus 1 plus 1, which will be 2t. So again plus this, what will this term go to? So e power minus of 2t minus half. So it will be minus of 2t minus 1. Again u of 2t minus 1 plus e power minus, what will this be? 2t minus 2, u of 2t minus 2. So what do you observe? So everything has been shifted to the left, right? This has come here, this has gone here, correct? This is like equivalent to n equal to 0, and this is n equal to 1, n equal to 2. So everything has moved left by 1 for t naught equal to minus half. You can take, if you take plus half, it will just move by right by 1, correct? And if you take like n by 2 for, let's say 3 by 2 and so on, according to this integer, right? Then it will just move left or right by so many number of terms. But since the summation itself is infinite, since the summation itself is starting and ending in minus infinity and infinity, moving left or right by finite number of terms, will not affect the sum or total sum. So we can say that it is periodic. It is actually periodic. Okay. So you can go through it once again if you did not get it in the first go. Okay, moving on. Question number 3. Consider the system properties. So we saw these properties, right? Memoryless, time invariant, linear, causal, and stable. Check these properties for the following systems. Okay, so what is the first system? Y of t is equal to x of t minus 2 plus x of 2 minus t. So first let us check for memoryless. It is very easy, right? So since y of t depends on other time instance than x of t itself, it is not memoryless, correct? Not memoryless. Because y of t depends on x of t at other time instance than t itself. Okay, because it's like t minus 2 and x of 2 minus t. Or for example, if you want to example, you can give an example. Y of 0 is x of minus 2 plus x of 2. So y of 0 depends on x of 2 comma x of minus 2. So it is not memoryless. It is a system with memory. So next, second property is time invariant. So time invariance. So what do you think? Is it time invariant? Okay, let's see. So x of t actually gives x of y of t as x of t minus 2 plus x of 2 minus t. Correct? So let's assume x1 of t as some x of t minus t naught. Now let's pass x1 of t to the system. So we'll get some y1 of t as x1 of t minus 2 plus x1 of 2 minus t. But x1 and x are related, correct? So x1 of t minus 2 is nothing but x of t minus 2 minus t naught. And x1 of 2 minus t is nothing but x of 2 minus t minus t naught. So here you just need to replace t with 2 minus t. So on the right hand side also you replace t with 2 minus t. It is straightforward. Okay, now you put it back here. So y1 of t is nothing but x of t minus 2 minus t naught plus x of 2 minus t minus t naught. But now let's compare it with y of t minus t naught. So y of t is here. What is y of t minus t naught? It is x of t minus t naught minus 2 plus x of 2 minus t minus t naught. So you are actually replacing your t with t minus t naught. So it's minus t here. So it will be replaced with minus of t minus t naught. So what will this come to be? This is t minus 2 minus t naught. Let's try to write it in this form. Plus x of 2 minus t plus t naught. You see the difference? So here it is minus and here it is plus. So y1 of t is not equal to y of t minus t naught. So it is time varying. In general, like if any x is like x of minus t dependence is there, it is generally a time varying system. You can try to generalize it for this case. Okay, that's how you learn, right? When you do an example, you need to try to see the big picture. You may need to apply it to other similar problems as well. So that is where the learning is. Okay, and then the next property is linearity. Okay, let's check for linearity. So we have x of t. Y of t gives x of t minus 2 plus x of 2 minus t. So let's take two sequels x1, y1 and x2 of t gives y2 of t is equal to x2 of t minus 2 plus x2 of 2 minus t. So now let's take a superposition of these two. So b x2 of t. So what will y of t be? So it will be a x1 of t minus 2 plus b x2 of t minus 2 plus a x1 of 2 minus t plus b x1 x2 of 2 minus t. Now you can try to group this, right? So if you actually see, this is, okay, let's take a x1 of t minus 2 plus x1, sorry, this is x1 of 2 minus t, correct? Plus b into x2 of t minus 2 plus x2 of 2 minus t. But this individual signals are also nothing but y1 of t and y2 of t. This is a y1 of t plus b y2 of t. So since y of t is equal to this, we say the system is linear. Okay, let me open another page. Okay, so they are linear. And the next property is causality and stability. Okay. Causality. Again we have y of t as x of t minus 2 plus x of 2 minus t, correct? Here, right? Okay. So what do you think? Is it causal? Okay, if we say this portion, okay, it depends on x of t minus 2. So it is actually like 2 time instance earlier. So you can say this looks like causal. But what about this? X of 2 minus t, right? What about that? Is it causal? Actually, it is not causal. For example, if you take any negative value of t, right? Let's say y of minus 1, then what you will get? X of t plus 1, or sorry, t itself is minus 1. So minus 1 minus 2 plus x of 2 minus of minus 1. So y of minus 1 is x of minus 3. This looks fine because minus 3 is less than minus 1, plus x of 2 plus 1, which is 3. If you see, y of minus 1 is depending on x of 3, but 3 is the future instant, right? So this is not causal because y of t depends on future values of x of t, right? Okay, then stability. So stability. So stability, what did we say? Bounded input should give bounded output. So this is called as BIBO. Okay. So let's assume that x of t is bounded. So it is less than or equal to some b. And b belongs to some number. It is less than infinity. Okay. It is some finite number. So what is y of t? Let's see the limits for y of t. So y of t is modulus of y of x of t minus 2 plus x of 2 minus t. And this is nothing but this is less than or equal to, we can take the modulus outside, x of 2 minus t. And each of this x is limited by b, right? It's just time shifting, but shifting and scaling in time doesn't change the amplitude. So these will itself be limited by b plus b. So the y of t itself is limited by 2b. So this is less than infinity. So y of t is bounded, which implies that the system is stable. So this is how you check. Now let's see the other example. So this is the function. Okay, first we'll start with memoryless. I think this is straightforward, right? So y of t depends on x of t minus 2. So it is not memoryless. So next is time invariance. So what do you think? Okay, x of t gives this y of t 0 for x of t less than 0, and x of t plus x of t minus 2 for x of t greater than or equal to 0. So let's take some x1 of t is x of t minus t naught. So similar procedure only. And now if we pass x1 of t to the system, we'll get y1 of t as 0 for x1 of t less than 0, and x1 of t plus x1 of t minus 2 for x1 of t greater than or equal to 0. Now we can just try, okay, now we need to write this in terms of x of t, right? So x1 of t is given and we need x1 of t minus 2. This is nothing but x of t minus 2 minus t naught. So now we can write y1 of t as 0 for x of t minus t naught less than 0. And here it is x of t minus t naught plus x of t minus 2 minus t naught. Correct? And x of t minus t naught for x of t minus t naught greater than or equal to 0, right? So now let us try to compare it with y of t minus t naught. We have y of t here. So it is 0 for x of t minus t naught less than 0. You just have to replace wherever t is there in the right hand side, you have to replace it with t minus t naught. And x of t will become x of t minus t naught plus t minus 2 will become t minus t naught minus 2 and x of t minus t naught greater than or equal to 0. So only difference you can see is here minus 2 minus t naught, here minus t naught minus 2, but both are equivalent, correct? These both are equivalent. So both are same. So y1 of t is equal to y of t minus t naught. So a shift in the input, time shift in the input of t naught results in an output which is also shifted by t naught. Hence it is time invariant. Cool. So the next is, I think, linearity, right? Yeah. So linear. So again, let's make a simple guess. Okay. So, but you can see the value of y of t depends on x of t, right? Whether x of t is negative or positive, right? Y of t functionally depends on the sign of x of t, right? So now let's assume some x of t which is positive. Let x of t greater than or equal to 0. Now if I pass x of t, what output do I expect? So I expect y of t to be x of t plus x of t minus 2, right? Now I send in the negative value minus x of t. So if it is linear, what should I expect? I should get minus y of t, right? But actually what do I get here? Since minus x of t is less than 0, I get 0 here, which is not equal to minus y of t, right? So this is not linear. This system is not linear. So sometimes you might also need to think out of the box to solve a question faster, right? Intuitive thinking. So next is causality. Correct? Yeah, causality and stability. Causality. So here again, y of t depends only on x of t and x of t minus 2. Y of t depends only on x of t and x of t minus 2, which are the past values of x of t. So it is causal, right? And stability, similar to the previous one, let x of t be bounded. So y of t, what is the maximum value it can take for each x of t? So it is less than or equal to mod x of t plus x of t minus 2, correct? And this is less than or equal to mod of x of t plus mod of x of t minus 2, which is nothing but less than 2b, which is less than infinity. Hence it is stable, right? So that is with the question. These are very good questions. So there are many good questions like this in the book. So please take a look at it. So now we'll look at the previous year gate questions. Okay. So the first question. The input and output of a continuous time system are respectively denoted by x of t and y of t. Okay. Which of the following descriptions correspond to a causal system? So we already know what is a causal system, right? So y of t should only depend on present or past values of x of t, right? So let's go one by one and check. So y of t is equal to x of t minus 2. Okay, this looks fine. And x of t plus 4. So this is a future value, right? So this is not a causal system. Second, y of t is equal to t minus 4, x of t plus 1. So this t minus 4 is we do not have to consider because it is not a value of x. So only whatever is there in the x we need to consider. But again, x of t plus 1 is actually a future value of x. So this is also not a causal system. And if you see the C option, it is actually depending on t plus 4 and x of t minus 1. So we should not confuse this t plus 4 with being the future value. It is only taking the t in the present. So t plus 4 only takes t in the present and does some operation. But x of t plus 1 is like x depending on t plus 1 is actually a future value. And x of t minus 1 is actually a past value. So this is a causal system. Okay, now let's also check the final option. Y of t is equal to t plus 5. So this is fine. But x of t plus 5, this is not fine, right? So the only option is option C, which is the causal system. Okay. Moving on. Second question. For a periodic signal, v of t is equal to 30 sine 100t plus 10 cos 300t plus 6 sine 500t plus pi by 4. The fundamental frequency in radian per second is. So still now we only found it for a single sinusoidal, right? But here what do we have? V of t is 30 sine 100t plus 10 cos 300t plus 6 sine 500t. 500t plus pi by 4. Okay. So now we have 3 signals. So now let's try to find out how to solve it for 3 signals. So let's consider them individually. 30 sine 100t, right? So what is the fundamental period for this? So in general, if you see for sine omega t or sine omega t plus 5, I will replace it with omega t plus t naught plus 5, which is nothing but sine of omega t plus omega t naught plus 5. So if this is equal to 2n pi, then it is periodic, correct? So what will be t naught? T naught is 2n pi by omega naught. So for 30 sine 100t, what will be the t naught? I'll take it as t naught 1 is 2n1 pi by omega naught. Omega naught here is 100, correct? And for 10 cos 300t, what will be t02? 2n2 pi by 300. And for 6 sine 500t plus pi by 4, what will be the time period? T03 is 2n3 pi by 500. So now we have 3 time periods, right? And for it to be periodic, there should be some t naught. Some t naught such that x of t plus t naught is equal to x of t. But each of them individually, they occur at t01, t02 and t03. So if there are some n1, n2, n3 such that t01 is equal to t02 equal to t03 equal to some t naught, then we can say this x of t as a whole itself is periodic at this t naught, right? So this is the condition. So you can actually take a moment to appreciate this fact. and then we'll proceed. Feel free to pause the video. So now we'll just try to substitute this. So 2n1 pi by 100 is equal to 2n2 pi by 300 is equal to 2n3 pi by 500 is equal to some t naught, right? So we can divide by 2 pi. So we'll get n1 by 100 is equal to n2 by 300 is equal to n3 by 500 is equal to t naught by 2 pi. So if you observe, n1, n2 and n3 are integers. So this is possible only if the denominator are such that they are HCF, right? HCF of denominator terms is also integer, or at least it should be real, right? Or at least real. Okay, now let's try to find the HCF. So HCF of 100, 300 and 500. You can see 100 is the common terms, like 100 divides 300 and 500. So it itself will be the HCF. So now we can actually write the n1, n2, n3 terms, right? So n1 is 1, n2 is 3, n3 is 5. So what will be t naught? T naught will be, t naught by 2 pi is actually 1 by 100. So t naught itself is 2 pi by 100. And in general, it can be 1 into some n. 1 into n, 3 into n, 5 into n. So this will be n by 100. So this will be 2 pi n by 100. And the minimum t naught fundamental is 2 pi by 100 for n equal to 1. And what they are asking actually, they are asking fundamental frequency in radian per second, which is nothing but omega naught. And omega naught is 2 pi by t naught, right? And which is nothing but 100. So 100 radians per second. So the answer is 100. So if you have to solve it intuitively and very easily, you can see if sine 100t and 300t and 500t are nothing but the harmonics, are sine 300t and sine 500t are harmonics of sine 100t. So these signals, sine or cos, right? Cos and sine 500t are actually like their frequencies is integer multiple of integral multiple of this 100, right? 100 radian per second. So hence the fundamental frequency of the sum also will be the lowest of the frequencies, which is nothing but 100 radian per second. On the time axis, if you see, it is actually the highest of the time period of among these three, correct? But on the frequency, it is actually the lowest. Okay, moving on. So the third question, consider a system with input x of t and output y of t is equal to x of e power t. Okay, it's a very different signal, right? E power t. The system is, okay, they're asking for either it is causal and time invariant, non-causal and time varying, causal and time varying, or non-causal and time invariant. So they're asking for causality and time invariance. So causality is straightforward. If I take y of 0, then it depends on x of e power 0, which is nothing but x of 1. So this is not causal. So what we have eliminated? This we have eliminated, this option and this option. So now we need to see whether it is time variant, invariant or time varying. Okay. So again, let's take our usual approach. x1 of t let's pass x of t, we get y of t as x of e power t. Let's take x1 of t is x of t minus t naught. So x1 of t will give me y1 of t, which is x1 of e power t, right? And actually x1 of e power t is nothing but, from here I need to replace t with e power t, which is nothing but x of e power t minus t naught. So y1 of t is x of e power t minus t naught. But what is y of t minus t naught? So y of t is here. Y of t minus t naught is x of e power t minus t naught. It is in the exponent. Because wherever there is t, there only I need to replace it with t minus t naught. And you can actually see clearly that y1 of t is not equal to y of t minus t naught. Right? So it is time varying. In general, if you see all these signals, x of t square, x of t cube, everything, some function of t, right? It is actually like time varying signals only. And the exponent also is a time varying signal. So, the correct option is non-causal and time varying. This is again wrong. So, these are all very nice questions, right? So, let's solve our final question. This was asked in GATE 2022. So, the outputs of 4 systems S1, S2, S3 and S4 corresponding to the input signal sin t for all time t are shown in the figure. So what they are given is, they have 4 systems and just for one particular input, which is the sin of t, they have given a output, right? Based on the given information, which of the 4 systems is or are definitely not LTI? So there can be more than one correct option. So what is LTI here? It is not LTI means it is not linear and not time invariant. So it is non-linear and time variant. Time varying. So definitely, if any one of, like if the signal is non-linear or time varying, right, then we need to choose those options. So now let's go ahead and see one by one, right? So for the first thing, it is sin t is equal to, give sin of minus t. So at first case, if we check, it may seem like it is actually like it is linear, but it is like time varying, because we saw that for x of minus t, it is a time varying signal. But if you actually see for this particular case where it is sin t, sin of minus t is nothing but minus sin t, correct? So we can also interpret this as minus x of t. So for particular value of sin, for this particular signal, this actually is equivalent. So we can't say that it is time varying actually. So if we take as minus sin t, then this interpretation we can take it. And this is actually time invariant. And what about linearity? It is just having a minus sign, right? So it is linear. So it is actually can be a LTI system. So it can still be an LTI system. Okay. So we can't disprove with this example. So for the second case, sin t gives sin of t plus 1. So this is straightforward. So this is something of the sort like t plus 1, right? And if you take sin t minus t naught, it is going to give sin of t minus t naught, t minus 1 minus t naught, which is actually equal to sin of t minus t naught minus 1. So this is time invariant. Time invariant. What about linearity? It is going to be linear, right? Because x of t plus 1 is a linear system. You can check it, right? You can just take 2 signals, ax1 of t plus bx2 of t, and it is going to be linear. The third one, sin t gives sin 2t, right? Now if you actually take pass and sin t minus t naught, it will actually give sine of 2t minus t naught, correct? Which is nothing but sine of 2t minus 2t naught. But the output should actually be sine of 2t minus t naught. Because there is shift in only t naught in the input, the output also should actually shift by t naught, but it is shifting by 2t naught. So this is not a time invariant. So just proving that it is not time invariant and any one, either linear or not time invariant, is enough to say that it is not LTA. Because LTA system should satisfy both these conditions, linear and time invariant. Since this doesn't satisfy time invariance itself, we can say S3 is not an LTA system. And the fourth signal, sin t gives sin square t. Again, this is not going to be a linear system, right? Linearity is lost because of the square. It is like some x square of t, kind of. So linearity is lost. So S4 is also not going to be an LTA system. But S1 and S2 we cannot still say. And actually, like, since many people have interpreted this as x of minus t, they would have considered that it is not a time invariant system. And many people have lost marks in this particular question. So although at first the question seemed very straightforward, gate is little bit tricky. So that's all for today. I hope you all had a great session. Please go back and do your practice as well. Bye. Take care.